Hello, gentlemen. Welcome to the last topic that we have to cover for week one. It's actually on quadratic functions, which should be somewhat of a review for you guys. We'll probably go into a little bit more detail than you have in the past, but there's two videos on quadratic functions, and let's just get that started right now. So let's just talk briefly about what a polynomial is. A polynomial is a function of this form, a sub n x to the n plus a sub n minus 1 x to the n minus 1, etc., where a sub n, these a sub n terms are the coefficients, and the leading one is not 0. And this is just called a polynomial function with degree n. And so if I had a function, for example, right here, f of x is 3x to the fourth plus 2x squared plus 1, the degree here is the highest power that we have, and that's going to be 4. Okay? This is a polynomial of degree 4. This one would be a polynomial of degree 5, like that. Okay. Well, right now we're interested in polynomials of degree 2, which are called quadratic functions. So a quadratic function is in the form of ax squared plus bx plus c, where a is not equal to 0. Its graph, as you guys should all recall, is a parabola. And if a is greater than 0, then the parabola is going to open upward. And if a is less than 0, we're going to have a parabola that opens downward. Okay, so again, hopefully that's somewhat of a review for you guys. Let's talk about some of the properties. We talk about axis of symmetry. Basically, if I put a mirror right here, this graph, it reflects over this axis of symmetry. And we have a vertex. Okay, the vertex here is a relative minimum value, and you could find that using your calculator. And we'll actually use this in word problems to find minimum costs, for example. And this would be when a is greater than 0, it's open upward. When a is less than 0, we open downward. We have our vertex now is a relative max. Max profit would be an example of why we'd want to find that value. Note the axis of symmetry goes through the vertex. Okay, so that's something that you should realize. Here's the standard form of a quadratic equation. A is equal to x minus h quantity squared plus k. The line of symmetry here is the vertical line, x is equal to h. The vertex is the point hk. All right, and if a is greater than 0, we already saw the parabola opens upward. If it's less than 0, it opens downward. Okay, so this is important to know. We're going to work on putting a quadratic equation in standard form now. This is a pretty straightforward problem. Write the standard form of parabola with vertex -2, 5, and passes through the point 0, 9. Just make a note here. We'll take some notes. Let me get my pen going. Okay, there's the standard form. Because I have my vertex already, I can write down that h is equal to -2 and k is equal to 5. So I know those two things. I can plug those in here, right there. And so now the challenge becomes I need to solve for that a, and that's where this other point comes into play. Okay? Now if I want to solve for a, I can plug that point in. I plug in 0 for x, and I know the value, the output is going to be 9. And so this simplifies down to a times 2 squared, right here because I plugged in 0, plus 5. And I can solve that 4a is equal to 4, and a is equal to 1. And so my final equation is x plus 2 squared plus 5. And note that my vertex here, I should note that my vertex is -2, comma 5. Put that in there. -2, comma 5, hk. And the equation of my axis, my line of symmetry, is x is equal to -2. And I knew that because I got that from that information right up there. Okay? Let's do another one. This one's a little different. This is a little bit more challenging because I'm giving it x squared plus 10x plus 14. Now I want to write it in standard form, but I'm not given the vertex. And so what we need to do in this particular example is to complete the square. I'm sure this is a blast from the past for you guys. But basically what I want to do, I have my x squared term. I take half of my b term. half of the 10x, half of 10 is 5, and I square it, and I get 25. And so what I'm going to do is add 25 and subtract 25. And that's what I'm doing here. By doing this, I'm not changing the equation in any way. And then when I do that, I can break it down into here. Now this part right here, I can factor. It's a perfect square. That's what completing the square does. This is going to be x plus 5 squared. Like that. Okay. And what does this tell me? Well, this tells me that my h is negative 5 and my k equals negative 11. So what I know when I graph this, that my vertex is at negative 5, negative 11. It tells me my line of symmetry is the line x equals negative 5, that vertical line. Okay, and here you have axis of symmetry, x is equal to negative 5, vertex is negative 5, negative 11. Okay, let's do one more. This one's a little more challenging. I know you guys like challenging, so here we go. Again, we need to complete the square, but the difference is I had a leading coefficient here. So I'm going to just group these two terms together and factor out a 2. That's what I'm going to do. If I look at inside here, inside the parentheses, I got to take half of negative 8, which is negative 4, and square it. So it's plus 16 minus 16. Again, I'm not changing the value here. I'm interested in this part right there because that's going to be my perfect square. So I want to bring this outside the parentheses. But before I do, I have to distribute that 2. And so I'm going to rewrite it like that. That's why this is negative 32, because I multiplied by 2 and brought it outside. Now this part right here, that's a perfect square. And if I simplify down there, I have 2. Now my a here is 2. X minus 4 quantity squared minus 1. So here, let's write it out again. H is equal to 4. K is equal to negative 1. So my vertex should be the point 4, negative 1. I should have my axis of symmetry should be the vertical line. X is equal to 4. Okay, and there it is like there. Okay, so there are a couple examples. Here's some homework. I want you to read section 2.1. Look at these examples here, fellas. Here's some problems that I want you to work through. And check this demonstration out. This demonstration is another really good one from Wolfram Alpha. It's definitely worth your time to do that. So to summarize, we looked at quadratic functions. We looked at the standard form of quadratic functions. We talked about the vertex. We talked about the line of symmetry. And we worked on completing the square to write a quadratic function in standard form. All right? Any questions, fellas? Just email me. All right? One more video to go and we'll be done week 1. Have a good day.